right, class, now I want us to talk about estimating population proportions. So we're going to be calculating confidence intervals for population proportions instead of population means. So it's nice to remember that a proportion can be represented as a decimal or a percentage. Okay, so population proportions are going to be between 0 and 1, so between 0% and 100%. Here we have our symbols that we're going to need. So we've got P, which is our population proportion, P hat, which is our sample proportion, Q hat we're going to talk about later, which is 1 minus P hat, our standard z-score, separating the area of alpha divided by 2 in the right tail of our normal distribution, our desired or just given margin of error, and our sample size. So for our confidence intervals, what we do is we take P hat minus RE and P hat plus RE, which is our error bound. This is how we calculate our confidence interval. Here's our formula for E, which is Z sub alpha 2 times the square root of P squared times Q hat divided by N. Where Q hat, it's important to know, is 1 minus P hat. When we're calculating our sample size, I'm going to take Z sub alpha 2 times my P hat times Q hat over E squared. And this is how we calculate our desired sample size when we're given an error. So again, if I want to calculate a 95% confidence interval, that means I need to use a critical value of 1.96. So 95% of our sample means lie within 1.96 standard deviations of the population mean. For a 99% confidence interval, I'm going to need to use a critical value of 2.575. So 99% of our sample means lie within 2.575 standard deviations of the population mean. And for a 90% confidence interval, I'm going to need to use the critical value of 1.645, right? So I am 90% confident that that means that 90% of all sample means lie within 1.645 standard deviations of the population mean. So here's how we find our confidence interval. Let's go ahead and practice how to find a few of these. So the Nielsen rating for television use a random sample of households. A Nielsen survey results in an estimate that a women's World Cup soccer game had 72.3% of the entire viewing audience. Okay? Assuming that the sample consists of 5,000 randomly selected households, we want to find the margin of error and the 95% confidence interval for this estimate. So I'm definitely going to need to find my margin of error. So the first thing I want us to note is that the calculate error, we have Z sub alpha 2 times P hat Q hat divided by N, the square root of that. Okay, here's our equation. So we now have that my error equals Z sub alpha 2. This is chosen by the fact that we want a 95% confidence interval. So I go to our table on the couple slides ago, I get 1.96. Now when it comes to P hat and Q hat, right, we're going to want to write P hat as a decimal. So in this case, P hat is 0.723. And my Q hat, my Q hat is 1 minus 0.723, which is going to be 0.277. So I'm going to take 0.723 times 0.277 divided by my N, which is 5,000. That's a big sample size. And I get 0.012. So in order to calculate this confidence interval for my true proportion, I'm going to take p hat minus my error and p hat plus my error. That gives me 0.723 minus 0.012 and 0.723 plus 0.012. So I get a confidence interval of 0.711 to 0.735. So between 71.1% and 73.5%. Next, in a survey of 50 randomly selected individuals in a large company, 38 said they like driving a car to work every day. I do not like driving a car to work every day. So staying home at this moment, it's not so bad. At least I don't have to drive. Think of the positives. So, assuming that I take a sample size of 50 random individuals, randomly selected individuals, I want to find my 99% confidence interval. So, I'm looking for a sample proportion, but they didn't give me one. I have to calculate it. I know that 38 out of 50 said they like driving to work every day. That's going to give me 0.76, which is our p hat. All right. I'm going to take my error, which is going to be z sub alpha over 2, times the square root of p hat q hat over n. Since I'm finding the 99% confidence interval, my z alpha over 2 in this case is 2.575. My q hat is going to be 1 minus 0.76, which is 0.24. So I have the square root of 0.76 times 0.24 over our n, which is 50. And I get 0.157. So I'm going to round this to 0.16. So in order to find my true population proportion, I take 0.76 minus 0.16 and 0.76 plus 0.16, right? This is our error. We're taking our population, our p hat, minus my error, and my p hat plus my error. So I get a confidence interval from 0.60 to 0.92. So that would be between 60% and 92%. That's a really big range. I don't know how confident I feel about this confidence interval. Last but certainly not least, I want to find what sample size I would need, okay, if I wanted to have a set error. So this is going to be the equation n equals our sample size equals our z sub alpha 2, right? Our confidence interval size matters, times p hat times q hat over our error squared. Okay. All right, so now we're going to calculate what sample size we would need to estimate the proportion of students on campus who carry a cell phone regularly. So I want to know how many students would be in my sample if I want a 90% confidence interval and a margin of error of no more than 4 percentage points. So I have that n equals z sub alpha 2 times p hat times q hat over e squared. And I'm trying to figure out what sample size I would need in order to construct a 90% confidence interval. So I'm going to go ahead and estimate my p hat because it's not given to me. Normally it will be given to you, but I'm going to estimate that it's 90% of students carry a cell phone regularly. I get n equals 1.645. That's my z sub alpha value from our 90% confidence interval. I'm going to take this times 0.9, which is our p hat. I calculate that q hat equals 1 minus p hat, so I get 0.1. So now I have 0.9 times 0.1 all over your desired error bound, which is 4 percentage points, but I need to convert that to a decimal, so that's 0.04. That 0.04 squared goes in the denominator. I then find 0.14805 over 0.0016 equals 92.53. So we're going to want to survey 93 students at least. Remember, we can't have 0.53 of a student.